Welcome back, students. So in this video we will discuss sign conventions for lenses that we already did for mirror. The same rules, but instead of mirror here it is lens. That's the only difference. Okay, the same 6 rules we will use it here, but there we used mirror, here we will use lens. That's the only difference. Okay. So I think for mirrors, instead of this lens, here it's a mirror, isn't it? So now here it's lens. So the distance measured to the right of this lens is taken as positive. Distance measured to the left of the lens is taken as negative. Then from the lens or from the principal axis, the distance which are measured downwards is taken as negative, which are measured upwards is taken as positive. So this lens is considered as the origin. From this lens, all the measurements are taken from this lens. Means from the optical center of the lens, all the measurements are taken. All the measurements are taken from the optical center of the lens. So here it's convex lens. So this one is the optical center. From this center towards the right is taken as positive. From this lens or from this center towards the left is taken as negative. This is the principal axis. From the principal axis, distance which are measured downwards, that is taken as negative. Distance which are measured upwards, perpendicularly upwards, that is taken as positive. Here also this one is a concave lens and this one is the optical center. The distance which are measured to the right of the optical center is taken as positive. Towards the left is taken as negative. This one is the principal axis. The distance which are measured perpendicularly downwards, that's taken as negative. Which are measured upwards, that is taken as positive. Okay. The same rules for mirror. The only difference there we use all the distance are measured from the pole of the mirror. Here we are using all the measurements are taken from the optical center of the lens. Optical center of the lens. So convex lens focal length is positive. Convex lens focal length is positive. That I will show you. Yeah, it's a convex lens and this one is a principal focus and this distance is a focal length. So we are measuring from the optical center towards the right. From the optical center we are measuring the distance towards the right. So this distance is taken as positive. So the focal length of convex lens is positive and yeah, it's concave. This is the optical center. This one is the principal focus. So we are measuring the distance from the optical center towards the left. Towards the left. So that distance is taken as negative. So focal length of concave lens is taken as negative because we are measuring from the optical center left towards the left, or we will say it another way, that is opposite to the direction of incident ray. Opposite to the direction of incident ray. Opposite to the direction of incident ray. We are measuring the distance opposite to the direction of incident ray. This is the direction of incident ray from left to right. So, this measurement is opposite to the direction of incident light ray. So, that measurement is taken as negative. If a measurement is taken in the direction of light ray, then it is taken as positive. Now, suppose I am drawing a convex lens here. This one is optical center. This one is F1, F2, 2F2, 2F1. Here, if the object is placed here, then that distance is known as the object distance, that is represented by the letter U. Object distance is represented by the letter U. So, object distance means the distance between the object and the lens. Distance between the object and the lens, we will measure it from the lens to the object. We will measure it from the lens to the object. So, it is in the opposite direction of the incident ray. Okay. So, from the lens to the object, this one is U. We are measuring, the light is travelling in this direction. This is the direction of light ray. That is the direction of light ray. We are measuring from the optical center to the object, that is opposite to the direction of the light ray. So, U is negative. Always U is negative. Okay, always U is negative. Now, when the object is placed between F1 and O, you will get an image here. You will get an image here. This one is the image formed by this object. Okay. So, we will measure the distance from the optical center to here. From the optical center to that image. That is V. And here in this case, V is negative. V is negative. Because we are measuring opposite to the direction of incident light ray. We are measuring opposite to the direction of incident light ray. So, when a convex lens produces virtual image distance will be negative. In all other cases, image distance will be positive. Image distance will be positive. Then, for concave mirror also, for concave lens also, U and V always negative. U and V always negative for concave lens. For convex lens, only in one case V will be negative, that is in case of virtual image. In all other cases, image will be positive, image distance will be positive or V will be positive. Here you can see in the first diagram, this one is the object, this one is the object. We will measure from the optical center, we will measure from the optical center, to here. This one is U. Okay. So, that distance is negative. Now, we will measure the distance V from here to here. That is in the direction of light ray. So, this V is positive. Okay. That V is positive. So, in the case of real and inverted image, you will get the distance, image distance as positive. In case of real and inverted image, you will get the image distance as positive, and in case of virtual image, you will get V as negative. Okay, V as negative. Then next is lens formula and magnification. Here mirror formula and magnification we studied. And mirror equation and magnification, the same thing. Here lens formula, that is 1 by f equal to 1 by v minus 1 by u. In mirror we studied 1 by f equal to 1 by v plus 1 by u. Okay. So, in case of lens it is 1 by f equal to 1 by v minus 1 by u. Okay. Now, magnification, the equation is same thing, height of the image divided by height of the object. But in mirror we got like this, m equal to minus v by u. Here in case of lens it is v by u. Magnification is m is equal to v by u. Okay. So, focal f, that is a focal length. For convex lens it is positive. For concave lens it is negative. U, image distance, that is the distance from the lens to the object. All cases u will be negative. Then v, image distance, that is the distance from the lens to the image. In case of real images, that v will be positive. In case of virtual images, this v will be negative. Okay. This u always negative. Now, this height of the image, height of the object is taken as positive. This height of the image is taken as negative. Here height of the image is taken as positive. So, in case of real and inverted image, height of the image is taken as negative. Height of the image is taken as negative. In case of virtual erect image, height of the image is taken as positive. So, lens equation 1 by f equal to 1 by v minus 1 by u. Magnification, that is v by u. So, in the next video we will do the problems related to this topic, lens equation or lens formula and magnification. Okay. Thank you.